Okay, well, good afternoon. My name is Paul Rogers. I'm the director for the U.S. Army's Tank and Automotive Research Center. And I have Dr. Harris, who's the director for AMRDEC. So we're going to split our time here and give you some insights into NGCV and future vertical lift. Okay? So what I do want to throw up, I can't see, if we can go to my first slide. I want to walk you through this. This is a quick introduction. And then at 1:40, we have on the main stage a broader discussion that includes the CFT and all those involved to talk more broadly about next generation combat vehicles. So if you're interested in that topic, I encourage you to come out and join us in the main auditorium to get, again, a broader view. So I am the director of TARDEC, which is a component of the Research Development Engineering Command. I know General Wins was up here earlier and talked, again, more broadly. But I'm going to focus just on the next-gen combat vehicle and hopefully put into a little bit of context. But in about 8 minutes of talking, I can only do so much. So I will try to get straight to the point. I do want to call your attention to the technologies corner. We were reset by the AAE in end of 2014 to focus in the years 2015 to 2019 on creating foundational technologies for the ground combat vehicle fleet. So we've been working that with our partners at TARDEC and AMRDEC to establish new technologies. Largely it's the active protection, it's the autonomous capability, it's the new powertrain, advanced powertrain, and a series of other technical fields. And that is coming to fruition here in 19. And those are foundational technologies that can then give us some leap ahead capability for the next generation of combat vehicles. So that's a foundational piece of our strategy. Then I want to call your attention over here to the architecture corner. You'll hear over and over again from all the speakers that the future is pretty unpredictable. And it's hard to anticipate exactly what our future capability needs are. Now, if you couple that with the fact that as you're engaged in conflict, the clock speed is moving quickly. And by clock speed, I mean the evolution of the threat and that cat and mouse, point, counterpoint, as you go back and forth. So as we are implementing capability, our opponent is changing the threat and changing the scenario on us. And it's always very costly and very time-consuming to evolve as quickly, so to get your clock speed of evolution on a ground combat platform to meet the clock speed of the evolution of the threat. So that's always the stressor. So what we've really focused on with that uncertainty of the future and then recognition that things are constantly evolving, we focused on fundamental architectures. And I'll go into a little bit more detail quickly on the next slide as to what those are. But what the focus of these architectures are is to give us an adaptable, more open architecture that we can bring new technologies to and rapidly evolve our systems as the threat is evolving. So that's the premise behind it. Between them is really the experimental prototyping, and that's what you're going to hear about with the next generation combat vehicle in the panel discussion. So we're working through the CFT and across the Army enterprise. We're working to figure out exactly what that future capability needs to be. And it's through this build, test, fix, build, test, fix paradigm, where we're more rapidly producing capability in the form of a prototype, putting it in the hands of soldiers, experimenting with it, learning from it, and then going back and redoing it. Okay? So a couple other points down here, the global market research. We are not wedded to our own technologies. We are in the midst of continually doing a global market survey. We are looking for the best technologies, the best capabilities, the most innovative projects from around the world. And we're looking to bring them in, and we can use industry's help in doing that. And then we are working with a public-private partnership. We're working largely through OTAs and through consortia. We don't want to get wedded to just one OEM at the front end of the program. We want to keep it open. We want to have as many partners with us, working collaboratively with us as we define what's in the realm of the possible, help the Army figure out what its key requirements are that it must have, and then building those into a program of record. And as that authorities transition over to the acquisition community, it will be their responsibility to then do that competitive activity and picking the supplier of that vehicle going forward. But at the early stage, before there's an MDD, before we enter into a formal milestone, we want to maintain this flexibility and have as many people participating with us as possible. Next slide, please. So this gets into some of those flexible architectures that I wanted to emphasize. And again, this is a much larger conversation. And if you want to get into more details about NGCV, there's right at the back corner back here, there's a group of folks that can show you what we're doing in each one of these architectures and talk to you in more detail. So I encourage you to go over and corner them and put them through their paces. Okay? So the architectures that we're focused on, the autonomy architecture, you heard this morning, if you were in the main session, the man-unmanned teaming is a key part of our future. We see it as a disruptive capability. We're leveraging a lot of what we've been doing over the last several decades in autonomous systems. And I think this is an opportunity with, I'm going to deviate a little bit here real quick. We have a flexible open architecture. We have behaviors that are already developed and well tested that are very mature. What you cannot afford to do if you're in industry is go out and repeat the development of that capability. It would be foolhardy. Come in, it's designed to be flexible. We have a library of behaviors and it's designed so that we give it to the next person who's developing a capability for the Army. So it's a library of behaviors and it's an open architecture. So come in and leverage what's already been developed. And then you can look at advanced powertrain and our scalable architecture there. We can talk about all of these. Lethality architecture, a lot of what AMRDEC is doing in ARDEC. The vehicle protection architecture, and this is based on our modular active protection program, the MAPS program, if you've heard that. Again, we're recognizing that the threat will be evolving very quickly. Our vehicle architecture needs to evolve as quickly if we want to match their evolution. So we're looking at an open architecture that can take active protection, both hard kill, soft kill, smoke, adaptive blast research, and adaptive capability or adaptive armor capability. So this is the brains and the architecture that stays in the vehicle while we adapt the outer effectors to respond to a given threat. So I'm hitting that very, very quickly, but in the booth right back here, they can get into more detail on maps. So, Dr. Harris, I'll turn it over to you now.
Good morning, I'm Dr. Harris. I am the director for AMRDEC, which is the Aviation and Missile Research Development and Engineering Center here at Redstone Arsenal. So I'm sort of your host, at least from the Redstone community. We also are one of the deck labs underneath RDECOM, and Future Vertical Lift, again, is another one of those examples of collaborative partnerships across the RDEC in order to meet the missions required for the Army. We have been working this one specifically under the FBL CFT with that leadership being led by Brigadier General Rugen. They will have their CFT outbreak on tomorrow, so please, if you want more details on that, please be sure to go to the larger auditorium area and therefore participate. But relative to Future Vertical Lift, the foundational base of Future Vertical Lift, again, is based on collaboration. The largest piece of it is, right now, the baseline piece of it is the joint multi-role technology demonstration that we are also in the process of actually achieving some of our first flight activities. But it's really, right now, for the JMRTD, it is a joint project. However, it is singly led by the Army. But they are utilizing an integrated IPT structure. But what I do want to make sure is that you understand from an FBL perspective, it is not just one vehicle. It is a family of systems. It's actually been targeted at your light, medium, and heavy class platforms. So one of the things that we've been doing right now with the joint multi-role was focusing on that heavy class of a configuration. What FBL is really looking for the future is actually achieving 2 times the speeds that we've normally had on some of our current aviation platforms. One of the things that we've been successful in, and that is in our partnerships also with industry. As you see, we already have a formal industry group called the Vertical Lift Consortium. So we have already been engaged with industry and industry partners as we look for appropriate solutions in the future vertical lift arena. If you'll go forward to the next chart. This just gives you an overview of those key S&T technologies that are required to move us forward. Really looking at the platforms, looking at the engine and power requirements that will be needed for the future vertical lift. Autonomous and unmanned systems. We're going to talk a little bit more about that one on the next chart. But how do we make sure we've got the appropriate unmanned systems that can match the speeds of these new vertical lift platforms? So that's one of the things that we're going to be focusing on. And then, of course, submission systems. Dr. Rogers talked a lot about the architecture. Well, the architecture for the future vertical lift configurations is very, very important. We've been working with the Future Airborne Collaborative Environment FACE efforts to look at open architecture structures because the threats will change, capabilities will change, and we have to have open architecture systems where we can plug and play in increased performance aspects, increased systems, etc. So that's a key basis of where we're going also. You'll go to the next chart. Next chart. Thank you. So specifically supporting FVL, FVL is not just the actual platform. That is a large piece of it, but it's also what are we going to do for the next gen tactical UAS. I talked a little bit about that on the last chart. We have to have UASs that can match the speeds of our new platforms. What is that really going to look like? So we'll be doing simulations, et cetera, to make sure we understand what the ConOps will be required to operate in situations like that. The high capability avionics and architecture, again, the whole open architecture approach, that is what's enabling us to move forward for the future. And then the integrated technologies. One of the key pieces going forward as a part of the CFT activities is what are we going to do in degraded visual environments. For future vertical lift, yes, brownout is a really big concern from a life and safety perspective. But we're looking at expanding DVE to be more than just for safety during brownout, but to actually provide a tactical capability under all environmental conditions. So we look at it as the three legs of the stool. One being the handling qualities, one being the cueing, and the other being the actual sensors that are on board. And that brings about why the whole future vertical lift capability area is truly a collaborative effort, because TARDEC comes to the table with a lot of the sensor activities and sensor fusion. ARL comes to the table with the human resources perspective on how do we make sure we're displaying the appropriate symbologies. And then as we go forward, there's the holistic situational assessment, situational awareness, as well as decision making. Those are things that are going to be needed to move this capability forward. And then advanced teaming concepts. How do we work? What does man-on-man teaming need to be? How much autonomy will we need? What are those capabilities that are going to take us forward? So from a CFT perspective, they are concentrating on these priorities, these activities as a part of their roadmap to provide those needed capabilities from an aviation perspective. And I think that is my last chart. So I'll open up for questions.
Okay, so that leaves us with about 5 minutes for questions.
Can you go back to your slide, if possible, the one you were showing, where you were pulling from industry? You had one particular slide, sir, you were showing it.
My first slide.
Yeah, global market research. How do you do global market research?
So we have gone out through a couple different mechanisms. One is we've used the breadth of AMRDEC and our presence around the world. AMRDEC has a lot of ITCs and people positioned in different parts of the world. So we've used that network to draw in information. And then also through our public-private partnership, we went out through industry and we chartered them to do the same type of global study. So they've reached out across their network of suppliers and other companies to look at what type of technologies are available out there and brought them in. I think the one gap that does exist is a lot with those small suppliers. They have they're not highly visible, so they may fall off our radar. So there's a lot of small innovative suppliers out there. There's also a lot of non-traditional technology developers that work in other markets and other private sectors that we could easily miss. So we're really trying to keep the site picture open for as long as we can, and then seek people who can bring in additional potential technologies and innovative suppliers.
This is the second part. And you're going on the 2014 timeline start, and then you're going forward from there. What you're saying. How do you build change in that process as you go through it for the ground? You're going to have technology changes. You're going to have something. So how do you? First article and then go from there.
Okay, so the question was around how do we build flexibility into our process and our vehicle so we can change over time as new things come to fruition. Okay, and that really gets to, let's go to my next chart please. That really gets to this architecture approach, where it is designed to be a flexible, more open architecture, where we are communicating the standards and the protocols and those interface control documents and the details of that to industry so that they have that a priori information as they continue to develop and mature their capabilities over time. And the goal here is to have that flexibility built into our architecture so as new capability comes, whether it's a replacement for something we already have, or if there's a placeholder so it can drop into a predetermined location. Now, that's the premise. That's the theory. And in practice, nothing is ever that smooth. But we're trying to involve industry on the front end. In fact, a lot of this work is being done through a consortia. MAPS is a consortia approach. We have 45 or 6 different companies actively participating on that program. There's only 7 or 8 that actually are funded by the government. The rest are doing it on their own dime so that they can help us shape the standards and protocols for MAPS. But then they also have that first-hand information that they bring back to their IRAD as they continue to invest and develop their technology. What that transparent communication allows is full awareness of the direction we're both going so that the possibilities of their capability matching with our control or an architecture is higher probability. That's the method behind it. But it's only as good as our communication and how open we are with industry.
Any other questions?
Sort of a follow-up on your architecture. How small are you looking to go? Are you going down to even drones in your architecture for a large drone as well as a small drone? So then I get into the organization like I do for cell phones.
So the question was around how small do we go, and use the term drones. And just for maybe clarity, typically when you say drones, that's your job, not mine. But, between the air and the ground, right now what we're looking at is collaboration between the two, but we're not trying to drive a common architecture. Aerial drones are much more further down the maturation path than ground combat vehicles. But for our perspective, we are going to a common architecture across the whole range of platforms. So we have a very mature architecture that we've developed and demonstrated for logistical resupply. We've mapped that architecture successfully on more than 20 different vehicles of varying sizes, to include NATO partner vehicles, and been very successful in demonstrating its maturity in operation. And now we're taking that very same architecture and we're mapping it over to ground combat systems. So as we go forward with next-gen combat vehicle, and we get into this next phase of building unmanned vehicles to partner with the manned vehicles, our premise is don't spend your money chasing autonomy. You'll go broke. And the Army won't be able to afford to sustain that software and those autonomous behaviors going forward. So come in and take what we've already invested in and use that as your foundation to build from. So you're now adding capability on top of what the Army has already demonstrated exists.
So, and I would...
as small as cell phones. Again, we're talking ground vehicles, so we're talking small pack bot.
But I mean, a drone that's as small, it's got multi-sensors, goes inside a building.
I think there's applicability there. From the architecture, yes, the behaviors are different. Behaviors tend to be based on the size and the inherent mobility of the platform itself. But the architecture is flexible enough to map across that. But again, come in, look closer, and if you see where we are missing something or our architecture doesn't work for something, we need to know that as soon as possible so we can fix those gaps.
So one of the things though that I would add is when you're talking about drones, of course that does look at your flight drones, but from an architecture perspective for FBL, we're looking at open architecture to be able to plug and play. But when we are interfacing now with the new drone, we have interoperability standards that you would have to meet to ensure that there can be communications appropriately to support manned-unmanned teaming or future swarming capabilities so that we have that information coming back to the cloud.
Very good. I think our time is up. Jeff Koshko, can you raise your hand? If you want to know anything about maps and modular active protection, attack him. And then NGCV and everything else from a TARDEC perspective is right in this booth back here. And then we have a panel at 1:40, so I'll see you there. Thank you.
Thank you very much.
Always, absolutely.